This is ISA 4220, Robert Seigan for Professor Green. Today we're going to be talking about AppArmor, HTTP, and HTTPS. First, we're going to talk about AppArmor. AppArmor is similar to SE Linux. SE Linux is used by default in Fedora and Red Hat operating systems, which is just another format of Linux. While they both work differently, both AppArmor and SE Linux provide mandatory access control or MAC security. In effect, AppArmor allows Linux developers to restrict the actions processes can take. Next, we'll look at security software for Linux, which is AppArmor. AppArmor is an important security feature that has been included by default with Linux. However, it runs silently in the background, so you may not even be aware that it's running at all. AppArmor locks down vulnerable processes, restricts the damage security vulnerabilities in these processes can cause. Installation of AppArmor. By default, AppArmor is already loaded, so you don't have, that's one less thing you have to worry about loading it up. You will probably just have to load up the profiles, which is the next thing we're getting to, AppArmor profiles. AppArmor does use profiles of an application to determine what files and permissions the applications require. Some packages will install their own profiles, and additional profiles can be found in the AppArmor profile packages. And then next, you can use AppArmor in conjunction with Firefox. So AppArmor can also be used to lock down Firefox for increased security, but it doesn't do this by default. So you would have to actually enable this feature if you want to use this feature. Since it's not enabled, because it may restrict Firefox too much and cause problems. Next, we could talk about HTTP. HTTP stands for Hypertext Transfer Protocol. HTTP is a request response protocol in the client-server computing model. When you enter HTTP, in the front of an address bar, in front of address, it tells the browser to connect over HTTP. I'll give you an example. When you enter in like a URL of http://www.cbs.com in your web browser, this sends an HTTP command to the web server to fetch and transfer the requested web page. When you enter HTTP in the address bar in the front of the domain, it tells the browser to connect over HTTP. HTTP uses the TCP or Transmission Control Protocol, generally over port 80, to send and receive data packets over the web. First version of HTTP was published in 1991. It was HTTP/.9, which was only considered of the one HTTP request method, GET. Next is HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure, also referred to as HTTP over TLS or HTTP over SSL. Next, how it works. HTTPS transmits its data security using an encrypted connection. Basically, what it does is it uses a public key, which is then decrypted on the recipient side. The public key is developed on the server and includes in what you know of the SSL certificate. Certificates are assigned by the certificate authority, or CA, and each browser has a list of CAs it implicitly trusts. and puts these web addresses in a trust file. Pretty much all these certificates. Any certificate signed by a CA in the trusted list is given a green padlock in the browser address bar because it proved to be trusted and belongs to that domain. When you enter HTTPS in your address bar in the front of the domain, it tells your browser to connect over HTTPS. Generally, sites running over HTTPS will have a redirect in place, so even if you type in HTTP, it will redirect you to deliver over a secure connection. So, which is always a good default. Typically, HTTPS also uses a TCP or transmission control protocol, just like HTTP, to send and receive data packets, but it does it over port 443 within a connection encrypted by the Transport Layer Security, or TLS. As of right now, right now, but as of April of 2016, 41.7% of the internet's most popular websites have a secured implementation of HTTPS. Some good practices for HTTP and HTTPS. If you're creating a website, you might want to obtain you do want to obtain a security certificate as a part of enabling HTTPS for your site. The certificate is issued by the Certificate Authority, or CA, which takes steps to verify that your web address actually belongs to your organization, thus protecting your customers from man-in-the-middle attacks. When setting up a certificate, you probably should look into setting up a 2048-bit key. I know some websites have certificates already, and there are weaker keys of 124-bit. It's probably best practice to upgrade it to 2048-bit key. The next one here, using server-side 301 and using HSTS, kind of goes together. Pretty much the 301 redirect is redirecting your users and search engines to the HTTPS pages or resource with the 301 HTTP redirect, which is basically the same thing as HTTP strict transport security, or HSTS. Good recommendations that HTTPS sites support HSTS. HSTS tells the browser to request the secured pages automatically, even if the user puts in HTTP in the browser or the location bar. It'll tell it to grab the secured page first. All this minimizes the risk of serving unsecured content to your users. Its main goal is to protect web users against some passive eavesdropping. As far as hardening your Linux system with AppArmor, AppArmor is pretty much just a security that's built into Linux. AppArmor has profiles, are similar to text files that are located in the AppArmor file. These pretty much have two main things to do. It can cut off processes, or it just restricts what programs can and cannot do, and what data it can see and what it cannot see. There are two main types of rules used in profiles. One's path entries, which detail which files an application can access in the filing system, like I just said, and compatibility entries, which determines what privileges a confined process is allowed to use. Like I said, this is already preloaded in the Linux software. At this point, it's just you have to come to a realization of what applications can touch, what they can't touch, and really set up just like a test profile and think of all these programs and what you want to secure and what you don't want to secure. That's pretty much what AppArmor does. And the best way to harden it is just think about what you have on your servers and what you want to have programs access to and what you don't want it to have access to, pretty much. So that's pretty much about all I have here on HTTPS, HTTP, and AppArmor. Thanks for listening.